Hi, grade 11s. Today we'll do some revision on your exponential graphs, and then recall that the standard form of the exponential graph in grade 11 is y is equal to a times b exponent x plus p. Note that the x plus p both are exponents, then plus q, which is a term on its own. Remember that q will form a horizontal asymptote of a graph. So it means that we will be, if we have a value here, we'll have dotted lines going that way over here in the graph, there, up or down. Now another thing that is important is about the b. The b value must always be a number bigger than 0, or b cannot be equals to 1. Now if b is between 0 and 1, you will draw a graph like this, meaning that if b, for instance, was a value, say for instance b was a half, then you draw a graph like this. If b was a number bigger than 1, say for instance it was 2 or 3, so it means then that your graph will be drawn something like that, going up, an increasing function. Now let's look at some of the examples. They say here we must sketch the graph y is equal to 2 times 3 exponent x. We can see that the q value, which was that, is 0, which means that our horizontal line, if we were to draw it on this Cartesian plane, will draw a horizontal line on 0 like that. So it will be a line over there on the y-axis. The next thing is this graph of ours has got the b value which is bigger than 1, and we said when b is greater than 1, the graph goes like that. So our graph will be drawn something like that. So which therefore means we need to work out what is the y-intercept of this graph. So the y-intercept of the graph, we know how to find the y-intercept. We make x equals 0. So where there is x, I plug in 0. Therefore, I have y is equal to 2 times 3 to the 0. So y is equal to 2 times 1, because 3 to the 0 is 1. 3 to the 0 is 1. Therefore, y is equal to 2. So this graph of mine cuts there at 2. Another thing to make things easier for the examiner to see, for you to see that, for him to see that you know your stuff, is to choose another point. Say, for instance, you choose when x is 1. Suppose there x is 1. If I put x as 1, so y will be equal to 2 times 3 to the 1, which is 6. Let's look at another example. Suppose they say I want us to draw the graph of y is equal to a third of x minus 3. We can see that the horizontal asymptote is at minus 3. So which therefore means that my horizontal asymptote be at minus 3. I'll draw it over there like so. So now I can see that also that the graph here is got the b value which is a third. And we said if the graph has got the b value which is between 0 and 1, between 0 and 1, so the graph will look something like this. So our graph will be coming somewhere like this, which therefore means that my graph will be cutting somewhere. It will cut the x-axis, but I don't know where it will cut the x-axis. I also don't know it will cut the y-axis. So I can try and find out where it cuts the y-axis. What is that? It's the y-intercept. Let's try and find the y-intercept. To find the y-intercept, we say x must be equal to 0. When you want to find the y-intercept, I put 0 there. So y is equal to 1 over 3 to the 0 minus 3. So y is equal to 1 over 3 to the 0 is 1 minus 3. So y is equal to minus 2. So the graph cuts at a minus 2. Note we said that dotted line is minus 3. So if I were to draw my graph would be cutting so and coming down like that. It's not going to touch the dotted line. And also, we need to work out now, try and find out what is the x-intercept. Now, to find the x-intercept, we make y equals 0. So, if y is 0, I plug in 0 there. So, I have a 0 is equal to 1 over 3 to the x minus a 3. Then solve for x. I can take it minus 3 to the side. 3 is equal to 1 over 3 to the x. Trying to solve for x, so 3 is equal to, I can raise this up, so it's 3 exponent and negative x. Note that the exponent of 3 here is 1. So 3 is the same as 3, therefore 1 is the same as minus x, which means that x is equal to minus 1. So the graph is cutting at minus 1 over there. Let's look at another one. Suppose they say we must sketch this one. We can see that this one here, the q value is 0, which means that our horizontal asymptote is on the x-axis again, like that. Now, this x minus 1. Now, that x minus 1, what is it telling us? It's telling us that our graph has shifted some units. So the graph there, that is a 3, so it's like that, but has shifted some units. So which means that I must try and work out what is the number there. So what is the number? How to find it? I work it out by finding the y-intercept. How to find the y-intercept? Y-intercept, we make x equals 0. So if x is 0, so therefore y will be equal to 3 to the 0 minus 1. So y is equal to 3 exponent 0 minus 1 is minus 1. So y is equal to 3 to the minus 1 is 1 over 3. So our y-intercept is a third. So it's cutting at a third. Okay, remember that's a 3, so it's an increasing function. So my graph will be doing something like that. Okay, now let's look at one more example. Suppose now they draw a graph for us. So this graph of ours is drawn, and then they say h at x is equal to a times 2 exponent x minus 1 plus q. They want us to find the values of a, that a value, and the q, which is that q. Remember what q was. Remember, it's the horizontal asymptote that is found on the graph. Let's look at our graph. Our graph has got a horizontal asymptote which is just there. So that is our q value immediately. So I know that q is equal to a minus 6. So in this equation, that is minus 6. That will help if you put it in the graph or in the equation of a graph. Let's find out. So I've got h of x, which is equal to a times 2 exponent x minus 1, and we said q is a minus 6. Put a minus 6 there. So we know that q is minus 6. They want a as well. A, as in previous graphs, we said a must always be the last thing to find. Even here, a is the last thing that we are trying to find. So how do I find a? Now, look how we can find a. We must know the value of y and know the value of x so that we'll know what is a. So choose a point. Point which is on the graph is this one here. X is minus 1 and y is minus 5 and a quarter. The substitute. So minus 5 and a quarter is equal to a times 2 exponent, and x is minus 1, then minus 1 minus 6. So I'm solving for a. So I can take minus 6 across. So if I take minus 6 across, becomes 6 minus 5 and 1 over 4 is equal to a times 2 exponent. Minus 1 is minus 2. Don't make a mistake and say 0. Now, what is 6 minus 5 and a quarter? Check. If you don't know, there is a calculator saying C, subtract a 5 and a quarter. The pattern with a 5 and a quarter is that one over there. So shift, it's a 5, then I can put a 5 in, then up 1, down there a 4. So I'm subtracting them. The answer is 3 over 4. The answer here is 3 out of 4 gives us an A. Now this 2 exponent minus 2 is same as 2 equals 1 over, so this same as 1 over 2 exponent 2. So which means that 3 over 4 is equals to A over 4. Obviously, if the denominator is the same as the denominator, it means that the numerator A is the same as 3. So A is equal to 3, we've got that, and Q is minus 6 as they asked. So therefore, you can do some revision. Of course, we said that the last time they can mix this with other types of graphs, the ones that we've done previously, straight line graphs, parabolas, or hyperbolas, but keep step by step and solve each graph as you go along. Step by step. Now, for your work is from www.brighterfuture.co.za, grade 8 to 11 papers. Do grade 11, DBE paper 1, 2015, question 5, only do question 5.2, and DBE paper 1, 2013, question 10, and SNK paper 1, 2015, question 8. I hope that will be easier for you to do. Okay, good luck, ladies and gentlemen.